Hi guys, this is Gopika here. As I said, I'm back with the third video of the chapter Similarity, and in this video we'll be discussing the first exercise of the chapter, and without wasting time, let's get started. Okay, so practice set 1.1, that is the first practice set of this chapter, and this is the first problem in your textbook. Okay, so base of a triangle is 9 and height is 5. These are the length of the base and heights. Okay, base of another triangle is 10 and height is 6. So there are two triangles, one with base 9 and height 5 and other with base 10 and height 6. Find the ratio of areas of these triangles. So this is the first property that we learned in the last two videos, that is ratio of areas of two triangles is same as the product of their base and height. Okay, corresponding base and height. So area of triangle 1 upon area of triangle 2 is equal to base 1 into height 1. Base 1 means base of first triangle and height 1 means height of first triangle, and base 2 into height 2. Okay, so base 1 is 9 and height 1 is 5. Okay, 9 and 5, and just substituting the values. Okay, base 2 is 10 and height 2 is 6. Now here with what we are dividing now, here 9 and 6 I can divide by 3. So 3 3s are 9 and 3 2s are 6, and here 5 and 10 can be divided by 5. So 5 1s are 5 and 5 2s are 10. So what is left? 3 into 1 in the numerator and 2 into 2 in the denominator, and therefore the answer should be 3 upon 4, and this is the reduced form. Okay, now once you substitute the values, the cancellation you can do even after multiplying the numerator and denominator. Okay, that is with you. Now this is the easier way I did. Now one more way we can do is 9 5s are 45 and 10 6 are 60. So 45 upon 60 you will get. With 15 you can divide both of them. So again you will arrive at 3 upon 4. Okay, so it's up to you that you do this calculation. Calculation part should be easy for you. Now you're in standard 10, and this calculation part you have done way back in 7th or 8th. Okay, so this is this you can choose how to calculate. Till substitution is the important part, and the calculation part you can do as you wish, but obviously in the correct way. So one way is cancelling with dividing, first dividing and then multiplying the numerator and denominator, or first you multiply the numerator and denominators and then you can cancel out. Okay, fine, simple. So let's move on to the next question. Okay, this is question 2. Let's read the question. In figure, BC is perpendicular to AB. BC is perpendicular to AB. Okay, AD is perpendicular to AB. BC is 4, this is 4 units, and AD is 8 units. Okay, then find area of triangle ABC upon area of triangle ADB. So we have to find the ratio of areas of these two triangles, the upper one and the lower one. Okay, so now in these two triangles, which is common? This base, they have a common base, that is AB. So by the property 2 or property 3 we can say that the area is, ratio of areas is proportional to the ratio of their heights, since the base is same. So let's see, in triangle ABC, base is equal to AB, height is equal to BC equal to 4. In ADB, base equal to AB, height is equal to AD is equal to 8. So therefore both triangles have same bases. Hence areas, ratio of areas is same as ratio of their heights, that is BC upon AD, that is 4 by 8. Now dividing 4 and 8 by 4, 4 1s are 4 and 4 2s are 8, the reduced form is 1 by 2. Okay, so area of ABC, triangle ABC upon area of triangle ADB is same as 1 upon 2. Okay, simple, common base, so the ratios are same as the ratio of their heights, and heights, the length of the heights are already given. Okay, so let's move on to the next problem. Okay, so this is the third example in the practice set 1.1. Now in adjoining figure, PS is perpendicular to RQ and QT is perpendicular to PR. If RQ is 6, PS is 6 and PR is 12, then we have to find QT. Okay, so how we how do we start, or how do we arrive at the first step? So first you observe the diagram and see what they have given. So PS is perpendicular to RQ. That means this information perpendicular, if we have a perpendicular in the diagram, that has something to do with the height of a triangle. Okay, that means in this problem or in this particular exercise I am talking. And when you again you have a perpendicular, that is QT, which is perpendicular to PR. If you again, this has something to do with the height of the triangle. Okay, now you got a hint. If you observe, PS is height of the triangle when we take RQ as base, and QT is height of the triangle when we take PR as the base of the triangle. Okay, now in either ways, area of the triangle PQR will be same. Whichever base and the corresponding height you choose, the final answer has to be same. Alright, and we are going to use this fact to find this value of the QT. Okay, so area of triangle PQR upon area of triangle PQR is equal to PR into QT. When PR is the base, QT is the height, and below we will take another way, that is RQ is the base and PS is the height. Okay, the values will be same. That means the areas has to be same, but in two different ways are we will consider it, so that we can find this QT, because rest three values they have given. So PR is 12, QT is that we have to find, and RQ and PS is 6. And here, since the area numerator and denominator is same, both will get cancelled, and what will remain is just 1. Actually it is 1 upon 1, but 1 upon 1 is same as 1. Okay, now this 6 into 6 is 36, and this 36 will go to the other side. Here it got divided, and here it will get multiplied. When the side changes, it will get multiplied. So 36 into 1 is 36. 36 is equal to the numerator, what is left is 12 into QT. Therefore QT is equal to 36 divided by 12. Again 12 changed its side, so the operation will change. Actually what we are doing is we are dividing both the sides by 12. So here 36 upon 12, and here when we divide that 12 will get cancelled. So only QT remains. Okay, QT is equal to 36 upon 12, and 12 3s are 36. So it will get cancelled, and the reduced form is QT is equal to 3. Fine, so we got QT. Okay, just observe the diagram, and whenever you see a perpendicular, especially in this chapter I am talking, when we have a perpendicular drawn, that means it has something to do with the height of the triangle in that figure. Okay, now let's see the next problem. Okay, so this is the fourth example of the practice set 1.1. Now adjoining figure AP is perpendicular to BC. AP is perpendicular to BC, and AD and BC are parallel lines. Then find area of triangle ABC is to area of triangle BCD. Now these both triangles have equal height since they are lying between two parallel lines. Okay, so this is the hint. So let's start. Construct DQ perpendicular to BC. Now I have constructed DQ to show the height of BDC separately. Okay, DQ perpendicular to BC. Given that AD is parallel to BC and AP is perpendicular to BC, DQ and AP have same values. That is DQ is equal to AP. Because if the distance between two parallel lines is always constant, perpendicular means obviously the distance between that lines. Alright. So AP and DQ should have same value, and let us assume it is H. It is H units. Okay. So let's start with the solution. Now triangle ABC and triangle BCD have a common base BC. For both the triangles, the base is common, that is BC. Therefore area of triangle ABC upon area of triangle BCD should be ratio of their heights, that is AP upon DQ. Now both of them have same value, that is H upon H. So 1 upon 1. That is area of triangle ABC is to area of triangle BCD is equal to 1 is to 1. The ratio is 1 is to 1 since the base as well as height of both the triangles are equal. Their areas are also equal. Hence the ratio should be 1 is to 1. Okay, clear? Fine. So let's see the next example. Okay, so this is the fifth question in your practice set 1.1. Now in adjoining figure, PQ is perpendicular to BC, AD is perpendicular to BC. Then find following ratios. So in under question 5 there are 4 sub questions. So the first one is area of triangle PQB upon area of triangle PBC. PQB upon PBC. Now if you see both PQB and PBC, the height is same, PQ. So the ratio of these areas of this triangle should be same as the ratio of their bases, and for PQB the base is BQ and for PBC the base is BC. So BQ upon BC, since triangle PQB and triangle PBC have same height PQ. Simple. Now we don't have values of BQ and BC, so this is what we have to write. Done. Now next sub question is PBC, area of triangle PBC upon area of triangle ABC. PBC and ABC. Obviously here the base is common, that is BC. So the ratio will be of heights. So for PBC the height is PQ and for ABC the height is AD. So the ratio is PQ upon AD, since we both of them have a common base BC. Now the third sub question is area of triangle ABC, ABC, the bigger triangle, the biggest triangle actually in this diagram, upon area of triangle ADC, ADC. Here both the triangles have a common height or equal height, that is AD. Therefore the ratio will be of the bases. So for ABC the base is BC and for ADC the base is DC, BC upon DC. Again, since triangle ABC and ADC have same height AD. Simple. When the height is same, the ratio is of the bases. When the base is same, the ratio is of the heights. Okay, now let's see the next sub question. Okay, the fourth sub question is ADC, triangle ADC and triangle PQC. Now here base is also not common, height is also not same. So the ratio is product of base and height. So for ADC, the base is DC and height is AD. So base into height means DC into AD. And for PQC, base is QC and height is PQ, that is QC into PQ. So this is the ratio. Now anywhere here they have not given any values, so this is what you have to write, and it's done. Okay, simple. So we are done with the practice at 1.1. I hope you understood all the sums. If you have any doubts, I will try to solve it, and please write it in the comment section so that I can help you out. Okay friends, so thank you for listening to me. If you like the video, please share it with your friends, and please subscribe the channel if you are new to my channel, and thank you. So see you soon with the next video of the chapter similarity, and the next video we will be discussing the basic proportionality theorem. Okay, so wait for me guys. Bye.